the files for our Jupyter notebook. You can go ahead and download those too if you want to run the code along with us. Hello, everybody. My name is Javier. I am a fifth-year transfer majoring in electrical engineering, and I'm also in the BSMS program, so I'll be getting my master's in circuits and systems pretty soon. I am the current electrical lead for Triton Robosub, and on the left, we have our website and our social media. Please feel free to follow us on Facebook or join our Discord. I'm excited to present to you this introductory workshop in digital signal processing with my colleague, Andrew.
All right. Hello, everybody. My name is Andrew, and I am an electrical team member for Triton Robosub, and I am also an officer for NeuroTech at UCSD. And if you want to learn more about NeuroTech at UCSD, you can feel free to check out the links to our website, Facebook, and Discord channel at the bottom right of this slide. So here's the layout for the workshop. And so we're first going to start out with talking about what digital signal processing is. Then we're going to talk about the breadth and depths of DSP. So therefore, we will be talking about telecommunications, audio processing, localization, and image and signal processing. Then we'll go into the fundamental knowledge topics. So here's where we will dive more into linear systems, convolution, and discrete Fourier transforms. And then finally, we'll end the workshop with a demonstration on audio filtering.
So what is digital signal processing? Digital signal processing is the math, algorithm, and techniques of manipulating signals. Signals can be pretty much any process you can think of, including things like seismic vibration, visual images, and sound waves, for example. Applications of DSP are endless, and some goals for it include visual image enhancement, speech recognition, and data compression, for example. In the next few slides, you'll see a little bit about what is possible with DSP, and really the applications for it are pretty much limitless.
Okay, so now on to the breadths and the depths of DSP. So DSPs have actually played an important role in advancing many fields of science and engineering, from fields including space, medical, commercial, telephone, military, industrial, and scientific. And in each of these fields, you have hundreds of DSP applications. Some of the applications that we will talk about in this presentation, as mentioned earlier, are telecommunication, audio processing, localization, and image and signal processing.
Starting with telecommunications. When you hear the word telecommunications, you may think of just telephones, but actually telecommunications is the transfer of information from one location to the other, with forms including regular telephone conversations, as we mentioned, to TV signals and to the internet and computer files.
Okay, so within telecommunication, you actually have three main methods of information transfer. You have multiplexing, which is the transmission of multiple data into a single channel. Then you have the second one, which you may be familiar with, compression. Compression is the reduction of the amount of original data stored. And then finally, there is echo control, which is the generating of anti-signals to canceling echoes in phone conversations.
On to the next topic of audio processing. So audio processing is a scientific field that has been revolutionized by DSP. Areas within this field include music and speech. I think we're both familiar, or we're all familiar with music and speech. So actually before DSP, the only way we used to be able to hear someone play the violin is if someone was like physically playing the violin in front of you, or it was recorded in an analog format. But now with DSP, we are able to turn signals from keys on a digital piano and make it sound almost identical to a real violin or any other instrument you can think of. And with speech, well, let's just say we could have had this presentation presented by our computers, But the reason we didn't is because engineers still have a lot to do to make computer sound or computer speech sound real.
Okay. And so in the case of techniques for audio processing for music, we have mixdowns. And in the process of mixdowns, DSPs provide filtering, signal addition and subtraction, and signal editing to make the process happen. A famous application of DSP in the topic of music is artificial reverberation. This application is for simulating various ideal listening environments. Now, in the case of speech, speech is actually split into speech generation and speech recognition. So in speech generation, DSP plays an important role in the digital recording and vocal tract simulation for computer-generated speech. Digital recording is the digitizing and storing of voices. So during this process, voices are digitized and stored in a compressed form. Then they are played back in an uncompressed form. Vocal tract simulation is the mimicking of human voices. The current dominant computerized speech is called concatenative speech synthesis, where people are recorded saying things and computers splice their words to make new words and sentences. It sounds so real and it's creepy, but it still lacks tone and emotion. Now, for speech recognition, we actually have two features. They are feature extraction and feature matching. The feature extraction comes first, then comes the feature matching. Each word in the incoming audio signal is isolated and then analyzed to identify the type of excitation and resonant frequencies. These parameters are then compared with previous examples of spoken words to identify the closest match, which is the process of feature matching.
Another field of DSP is echolocation. This is the process of obtaining information about a remote object by bouncing a wave off of it. And three main applications include radar, sonars, and reflection seismology. Radar is radio detection and ranging. So what is DSP's role in radars? Well, first, DSP can compress the pulse after it is received, providing better distance determination without reducing the operating range. Second, DSP can filter the received signal to decrease noise in detecting it. Third, DSP enables the rapid selection and generation of different pulse shapes and lengths. And this allows the pulse to be optimized for a particular detection problem. On the case of sonars, it stands for sound navigation and ranging. DSP has revolutionized sonars through pulse generation, pulse compression, and filtering detected signals. In active sonar, sound pulses between 2 kilohertz and 40 kilohertz are transmitted in the water, and the resulting echoes are detected and analyzed. In passive sonar, we just listen to underwater sounds, which can be, marine life or mechanical sounds coming from submarine or vessels. Reflective seismology uses similar principles as two previous ones in that we use DSP to estimate the properties of the Earth's subsurface from reflected seismic waves.
Okay, and so on to the last topic of DSP that we will be talking about, and that is image processing. We see that DSP plays an important role in image processing in the fields of medical, space, and commercial image products. In the case of medicine, DSP have played a significant role in CAT scans and X-ray scan. For space, DSP actually improves image quality in unfavorable conditions through brightness and contrast adjustment, edge detection, noise reduction, focus adjustment, and motion blur reduction. And in the case of commercial imaging products, DSP play an important role in image compression. And then now for the demo, I will show an application of image processing, where basically I will be doing color swapping of an image and graying out of images. Basically, what I'm going to be doing here is I'm going to be graying out on an image of myself right here. So I'll be doing out a gray out of an image of myself. So yes, this is a picture of me in front of fallen star before quarantine hit. And then I'll be doing out a graying out on Javier picture. Okay, so to show an application, basically Python color gray. So let's see what Javier's picture looks like when grayed out. Let's do a refresher. This is what Javier's picture looks like before the graying out. And here's a picture of Javier grayed out. Okay, and now let's see what I look like when grayed out. So here's an original picture of me. Now let's gray myself out. All right, so here's a picture again. Here's a picture of myself, and here's me grayed out. Yes, it looks pretty creepy, doesn't it? Now let's see what I look like when we do color swapping on my picture. Let's hope that this looks a little bit less creepy than me grayed out, at least. So let's do the process of color swapping on a picture of myself. Here's a picture of me color swapped. So as you can see, I now have the color of fallen star. Looks like the color of fallen star now has my skin tone. That's me color swapped. So basically I just look blue now. So basically, as you could see in the application that I demonstrated, DSP actually plays an important role in image processing techniques, such as swapping the color of images, graying out the color of images, resizing images, and cropping images. So that's DSP in the topic of image processing.
And if you want to see more image processing techniques, you can check out this link in the slides, or you can check out our Python notebook where this link is also there.
Okay, so to first get to know a little bit of our organizations, let's first start about getting to know NeuroTech at UCSD. So NeuroTech at UCSD is a club affiliated with a neurotechnology nonprofit organization called NeuroTech X. Our clubs actually started in January 2020 with the faculty advisorship of Professor Vikash Gilja of the TNEL Research Group. Our club has connections with a neural headset company called Wearable Sensing. Our club participates in annual NTX student competitions, and the mission of our club is to bring together students interested in neurotechnology and provide ways to get involved in the field.
And a little bit about TritonRobosub. We were actually founded pretty recently as well. We debuted in 2018 and got to the semifinals at the yearly International Robosub competition held at the NWIC Pacific Transtech Pool. Aside from competing, we also do research with Scripps and in conjunction with Engineers for Exploration. A current project we are doing right now is working on developing a handheld tool to measure fish population. And in Robosub, we do a little bit of everything from mechanical engineering and fabrication to computer science and machine learning and simulations to electrical engineering and circuit building, and of course, doing some digital signal processing.